Hello, everybody. Good morning in Europe and good afternoon in Southeast Asia. Thank you very much for joining us today in our Chemitec Waste to Value Solutions Valorizing Southeast Asia Wastes seminar. I'd like first of all to introduce our speaker, Mr. Mohammed Nasrullah, who's basically Dr. Nasrullah. He is currently working as a Chief Technology Officer in Waste to Value Development in Chemitec Consulting here in Finland. He holds a Doctor of Science degree in Chemical Technology from Aalto University here in Finland as well, in the capital region of Helsinki. His doctoral research was on materials and energy balance of solid recovered fuel production. And after his doctoral degree, he continued his postdoctoral research at Aalto University. For the last 10 years, he has been working in the field of waste to energy and waste to value, process developments and design. And he is mainly involved in research and development and design of commercial scale waste to value solutions. In the mentioned field, his expertise are in concept solution development, performing techno-economics and feasibility studies, and design and development of industrial scale waste to value solutions. Dr. Nasrullah, the word is yours, so please let us know and about waste to value solutions for Southeast Asia waste.
Thank you, Luis, for your introductory remarks. Hello to all. Good morning to our participants from Finland, Europe, and good afternoon to our e-guests, in this case, from Asia. From Chemitec Consulting OI, I'll be presenting to you all waste to value solutions we have been working on very actively in Europe and especially in Asia region. So I think my slides are visible to you.
Yes, they are. Yes, they are.
Okay, great. Right. So as I mentioned that I'll be presenting about waste to value solutions, and it covers techno-economics and environmental aspects of these solutions. And we will discuss about valorizing Southeast Asia's waste. So I kept the agenda simple and straightforward. And our agenda of the webinar is first introduction of Chemitec Consulting Oil. Then we come to our topic that what is the issue of waste management, why we need to be worried about it. And then we will come to the solutions to solve this issue. And finally, we will have a question and answer and discussion session. Right. So first, I'll introduce to you briefly about Chemitec Consulting Oil. We are a Finland-based, globally operating engineering and consulting company, and our areas of specialization are chemical engineering, process development and design, energy technology, and environmental technology. And we are now more than 30 years old. We have been operating in different parts of the world. We have conducted quite many projects in Europe, and also we are active in Asia and other parts of the world. Chemitec's head office is in Espoo, Finland. So basically we have conducted number of projects in chemicals related with chemical engineering, process development and design, and in energy, including waste to energy. Right. So these are waste to value related expertise and services Chemitec has been working on and offered to our customers and clients in different parts of the world. And these are starting from process concept to solution development, technology assessment for best available technology route, project scoping and baseline study, detailed techno-economics, project costing, pre-feasibility study, feasibility study, including basic design and pre-engineering. And we also are involved in arranging the technology for waste to value, waste to energy solutions. We are part of top waste to energy uh, technology supplying companies in Finland, and we also do project management in this area. So here is a list of projects we have worked on quite recently, actually, in waste to value, waste to energy related projects. We prepared a pre-feasibility study and delivered to our client in Mymensingh, Bangladesh, and it was about 5.5 megawatt electricity production waste to energy plant in Mymensingh. Then we also prepared and delivered pre-feasibility study for 23 megawatt electricity production waste to energy plant in Colombo, Sri Lanka. And we have prepared number of project proposals for different cases in Pakistan, including waste to energy plants proposals in Karachi, Lahore, Islamabad, Faisalabad. And very recently we have signed an agreement with the client in Bangladesh, and we will start working on this to deliver a bankable feasibility and pre-engineering study for 6 megawatt waste to energy plant in Shawar, Bangladesh. Right. So now we come to our main topic, which is about the issue of waste management. As I mentioned earlier, that why we need to worry about waste management. What are those things which are already getting alarming in this sector? So this study is basically conducted by World Bank Group about a global snapshot of solid waste management to 2050, in which they have presented region-wise the waste generation in the world. So here if we see the top 3 regions producing more waste than others. So first is East Asia and the Pacific, Europe and Central Asia, and South Asia, generating 468 million tons, 392 million tons, and 334 million tons, respectively, solid waste. And then there are other regions, North America, Latin America, and the Caribbean, and so on. Right. So important is to know that how basically those regions are treating their waste, how they are handling the waste which is generated in those regions. So having looked at South Asia region, it shows that the amount of waste being generated in that region, 75% of that ends up in open dumps. So those are not even proper landfills or managed landfills, but just open dumps, some place somewhere outside city, and where the waste is transferred and placed over there in open areas. So similarly, if we see Middle East and North Africa, 52.7% of the generated waste in that region ends up into open dumps. And also in Sub-Sahara Africa region, around 70% of generated waste ends up in open dumps. And there is, in those regions, basically very little waste material goes to proper landfills, and even little utilized for value recovery in terms of composting, recycling, or incineration. So here is this slide shows about the generated projected waste amount in world. So in 2016, it was around 2 billion tons, and it is projected to be 3.4 billion tons in 2050. So the trend is increasing, and basically it is The countries are developing fast, more urbanization taking place, lifestyle of people is changing, and so the amount of waste is also increasing. And talking about the Southeast Asian countries, here are some prominent countries in that region regarding waste to energy and waste to value related sector. In Vietnam, the annual waste generation is little more than 20 million tons, 22 million tons, and then Thailand, around 25 million tons, and Indonesia is the highest waste generating country in Southeast Asian region. So it is more than 60 million tons per day, per year. Right. So here is the composition of waste in those countries. These are taken from literature, so these might change from location to location, but generally speaking, this is the composition of municipal solid waste, which ends up in landfill. So basically, biofraction of waste is in significant amount, varies from 53.8 to 64%. And then the second significant fraction of waste comprises of the combustibles like paper and cardboard, plastic, textile, and some natural fiber-based textile and rubber and leather, etc. So this part contains waste components containing high calorific value, which can be separated and transformed to RDF, refuse-derived fuel, to be utilized in energy production plants and energy production processes. So basically, the message here is that there are two main fractions in this waste which contain value and which can be recovered quite significantly. So first one is this organic waste, food waste, and second is this combustible fraction, including, as I said, paper, cardboard, plastic, textile, etc. So these are the issues being caused by improper waste handling and improper waste management. As we saw, the amount of waste which ends up in the open dumps and unmanaged landfills. And then these dump sites occupy a lot of land areas. There is an issue of greenhouse gas emissions. Around 5% global greenhouse gas emissions belong to solid waste management sector. And in the open dumps or unmanaged landfills, it deteriorates groundwater quality because the leachate from those landfills gets leaked into groundwater, making its quality worse as a drinking water for nearby residents, and it also contaminates subsoil water as well. And then there are other issues like waste components end up in rainwater drains, sewage system, and so on. It's also a burden on country's healthcare system because it will affect negatively on the health of society. So in other terms, the burden has to be borne by governments. And last but not the least, it is waste of resources as well. Especially here in Europe, waste is considered as a resource from which energy especially can be recovered and other valuables can be recovered to benefit society. Now we will go through waste to value solutions Chemitec has developed and offered to customers in Europe and in Asia to tackle waste management issue by recovering maximum possible value out of the waste. So these are basically the approaches which are quite strictly being followed, especially if we talk about Scandinavia and European countries. And the first approach is about following the guidelines of waste hierarchy, starting from prevention, minimization, reuse, recycling, energy recovery, disposal. And the upper parameters are most favored and the lower parameters are least favored options. And second is about the shift from linear economy to circular economy. In linear economy case, basically raw materials are taken from the nature, used for manufacturing, and the products are used and thrown away. And then again, raw materials are taken from the nature. So in this way, basically, the raw materials comparatively fastly deplete. But in circular economy approach, the products produced are not thrown away directly, but still available value is recovered out of those products, which is recycled back to this loop. So here's the first solution, which is actually very important in addressing the waste management issue in long run, and which is about education and awareness to society. So it's about educating society that what is waste, what does it contain, prevention, minimization, reuse, recycle, value recovery, and proper disposal. And then explaining to them about the disadvantages of waste mishandling, that if waste is not managed properly, so what kind of issues it will create for the society, for city, for country, and for world. And on the other hand, if the waste is managed and handled properly, then what kind of benefits we can have from this proper management. And at the same time, some practical steps include introducing source separation based bin system at household level, designing source separated based waste collection system at society level, and designing and implementation of circular economy based waste management system at city level. And Chemitec Consulting Oil has been working in this area as well in supporting and assisting organizations or educational entities prepare material, preparing system and process for them to educate and aware the society about waste management issues. And now we will discuss about the technology part of waste to value solutions I mentioned about. And in this technology part, we will give a case study based on various assignments and projects we have conducted so far, especially in Asia region. And these techno-economics and environmental aspects of waste to value solutions are based on those case studies. So the numbers may vary for your specific case. It might be due to the quality of waste is different, the amount of waste available is different. However, the numbers may still be comparable. So we will also discuss those capex and opex value for those specific assignments and projects Chemitec has worked on already. So first solution is about circular economy based waste to value system. In this case, we have municipal solid waste, non-recyclable mixed waste, which is collected from household, commercial areas or other places, and which mainly end up in the landfill. So the at first stage, this municipal solid waste, mixed waste, is processed in mechanical treatment-based waste sorting plant. And depending upon the composition and nature of input waste, there may be different unit operations to be used in mechanical treatment plant. It may be bag opener or like material cutter, shredder, screening, ferrous metal separation, non-ferrous metal separation, and also this air classifier to take away the combustible lightweight waste components. And in some cases, there might be need of near infrared sorting units as well, because in certain cases it might be so that the input waste contains components containing high chlorine value, and we need to take it out from the waste so that it doesn't end up in refuse derived fuel. So basically, after mechanical treatment process, the input waste is segregated into different source streams. The first one is biomaterial. Then if there are some recyclables in terms of metal or glass or some others, and then RDF, refuse derived fuel. In some cases, it is solid recovered fuel with better quality. And the third and the fourth stream is inert. And we have observed that in mainly in South Asia region, there might be significant fraction of inert in the form of dust, soil, mud, concrete, etc. So after the mixed waste is segregated into these different streams, so each stream is further processed in its respective system. Like biomaterial is processed in biogas production plant, producing electricity from biogas through CHP unit, combined heat and power unit. And the digestate which comes out from the bioreactors passes through separation and drying technology, and biofertilizer is recovered from this digestate. And if we talk about this refuse derived fuel, RDF stream, so it is incinerated in combustion plant, producing electricity, and residues ash, bottom ash, fly and filter ash. And then inert contains a certain part which can be used as a construction material. And then the inert processing is done for that material. And also some amount of inert, it goes for landfill material. So here is one case study. As I mentioned earlier, that we will study a case study based on our experience with different projects and assignments in this area. So treating 1,000 tons per day of municipal solid waste, it will produce 4.2 megawatt hour electricity from biogas production plant side and 5.2 megawatt hour thermal heat. And basically this heat can be used within the process for biogas production plant when there is a need of thermophilic process, and also in separation and drying technology to produce biofertilizer. And then there is 50 ton per day of biofertilizer, 5 ton per day metal, and 17.5 megawatt hour electricity is produced from combustion plant section. And depending upon the composition of input waste, there can be 5 to 10% of input waste remains as material to landfill after processing. Right. And there is a second solution. It comprises of waste to energy based waste to value solution. So in some cases, if the customer is not interested to have anaerobic digestion facility for as part of their solution, and he is interested to incinerate most of the waste. So in that case, the biomaterial is not segregated as a separate stream, but from mixed waste, metals are recovered, or glass, if there is some glass as well. And also the inert material is segregated. And then most of the material is transformed into RDF form. And this RDF is incinerated in combustion plant, producing electricity and heat. And there is residue in the form of ash. And again, inert, partly it can be used as a construction material, and partly it is sent as a landfill material. And ash, depending upon the local rules and regulations, it is utilized. In some cases, it may be used as a construction material, but in some cases, it may not be used as a construction material, so it is properly disposed. And as I mentioned earlier, that there might be 5 to 10% of input waste remains as material to landfill after processing. And basically, an additional step in this process is that the input waste might be wet, containing moisture content of 50% or 55%. So here it would be required to evaporate water to dry this material. So in order to have a calorific value of RDF, which is suitable for combustion plant, which is like 8 megajoule per kilogram minimum we require in this case. And this heat is utilized to dry the input waste to increase the calorific value of RDF. So here, if we treat 1,000 tons per day of MSW, it generates some metal, 5 ton per day, and then 24 megawatt hour electricity from combustion plant. So basically, using only combustion and not using anaerobic digestion plant may increase the electrical output from 5 to 10%. And then there is a second major stream of waste, uh, especially if we talk about Asia region. So it is bio waste, which may contain agricultural waste, manure, slaughterhouse waste, wastewater sludge, and it is now source separated bio waste. It is not mixed with other components. So in this case, it doesn't require to be treated in a mechanical treatment plant, but straightforward, it is sent to feedstock reception silos and then feedstock preparation units. It might require some shredding, mixing with water if needed, and then it is a ready-made material feedstock for anaerobic digestion system, where from biogas electricity can be produced, or if customer is interested, it can be transformed to biomethane, which is an industrial fuel replacing natural gas, and also it can be used to produce compressed natural gas or liquefied natural gas as a fuel for public transport. And as mentioned earlier, the digestate coming out from anaerobic digestion, it passes through a separator system technology producing biofertilizer. And here, if we process 500 tons per day source separated bio waste, kitchen waste, so it can produce 9.5 megawatt hour electricity and also a thermal heat, which can be utilized in biogas production plant and also in biofertilizer separation setup, or it can produce 52,000 normal cubic meter per day of CNG or LNG, or it can produce around 52,500 ton normal cubic meter per day of biomethane, or it can produce a mix of these products depending upon the client's need and requirement. And here is one process which Chemitec has recently developed, and we offered this process also to one customer in Sri Lanka. It is about clearing old open dump sites and unmanaged landfills of waste material. And it is basically the concept is developed to clear the land area which is covered by material, with waste material for last many years. For instance, in some cases, the open dumps might be operating for last 20 years, 25 years, 30 years, or even more. And the land area, and this occupies a significant amount of land area, might be hundreds of acres. So in this case, the waste is excavated from open dumps and landfill and is mechanically treated, where it is sorted out into recyclable. There might be some metal which can be recovered and recycled. And then there are two main streams, because most likely in these open dumps and unmanaged landfills, which are there for many years, the biofraction and also some paper and natural fiber-based textile most likely are degraded completely and turned into sort of soil already. But plastics and some rubber, etc., more likely are still there. So this combustible fraction containing plastic and rubber can be recovered from this. And the second major stream is this non-combustible material. And combustible can be transformed into RDF, which is a very good fuel for waste to energy plant containing good calorific value, producing electricity and heat. And then this non-combustible material, which is inert, it is processed in the post-sorting processing system, where heat produced from the waste to energy plant is utilized to process this type of material. And basically, this heat helps to remove some toxic elements or some bacteria which make this material of no use. But after processing, this certain part of this material can be used as a construction material for specific applications, and the rest is material for sanitary landfill. So basically, the major value which will be recovered from this setup is the recovery of land after all the landfill material is processed, and using that land area for better use of society. Right. So this is the summary of solutions I have described so far. So basically, first is this MSW, as I mentioned, that treating it in mechanical treatment plant, and then segregating this into different resource streams, and then each stream is processed accordingly in further process, recovering maximum possible value out of it. And second stream is of bio-waste, source segregated bio-waste, which can be directly used in anaerobic digestion plant. And then we have also this forestry waste. It includes branches and leaves, stump chips and barks. So it requires some fuel preparation like shredding, particle size distribution, and then incinerating it in combustion, gasification, or pyrolysis systems producing energy. So this was the technology part. Now we will go through the economical part of these solutions. And when we talk about economical part, so what comes to our mind is CapEx, OpEx, and revenue generating streams. So here CapEx mainly includes equipment cost, engineering, procurement and construction, civil infrastructure, land area requirements. Mainly these are the major sections which are included in CapEx, and OpEx includes materials cost, utilities related cost, maintenance and spare parts, and workforce cost. So estimated CapEx for those specific projects or assignments we have worked with, and the estimated CapEx does not include here the civil works like building construction and infrastructure related activities and cost of land required as plant site. So if we talk about biological treatment from source separated bio-waste, and the estimated CapEx for this system is 3 to 4 million euros per megawatt hour electricity production. And if it is a mixed waste and the process is mechanical biological treatment, then the estimated CapEx is raised to 3.5 to 4.5 million euros per megawatt hour electricity production. And if we integrate it with combustion plant as well, then it is a mechanical, biological, and combustion treatment of municipal solid waste. Then the capex value increased to 5 to 5.5 million euros per megawatt hour electricity production. And just to mention again that it does not include civil work related activities like building construction and infrastructure related activities and cost of land required as plant site, because basically this may vary significantly from location to location. For instance, in Europe, workforce is expensive, so it will be expensive, but in some part like in Asia, it is less expensive, so the capex numbers would be less additional to those numbers. Estimated OpEx, we talk about mechanical treatment of MSW. This is in case if a customer is interested to produce RDF or SRF and to use it for cement kiln industries or for power plants, etc. Then here is maintenance and spare parts is 1.4 euro per ton material processing. Then there is electricity consumption and also workforce cost would be in addition. Then we come to biological treatment of biomaterial. So maintenance and spare parts around 1.7% of plant's investment. Then there is in addition electricity cost and other utilities and also work cost. It depends on the case to case. And for combustion treatment of waste, for instance in RDF, the maintenance plus spare parts plus material chemicals and ash handling would be around 1.5 million euro per year. And then there is electricity consumption. That is around 13% of the produced by plant, and then workforce depends on the case to case. And as I mentioned that economics, it also includes the revenue generating products. So basically these are those revenue generating streams which will be marketable after implementation of these waste to value solutions. So depending upon the requirement and needs, it might be electricity, heat, RDF, SRF, CNG, LNG, or others. And in some cases, These waste to energy plants can also be integrated with desalination plants, producing clean water for the society. And in addition, the benefits are clean cities, circular economy, clean renewable energy, reduction in greenhouse gases. Now we come to the last part of our presentation, and it is about the environmental aspects of waste to value solutions. As I mentioned earlier, that around 5% of global greenhouse gas emissions belong to solid waste management sector, and basically the solution would provide a solution to also because this is a solution to problem of groundwater quality deterioration by landfill leachate, and also alternative to fossil fuels, positive effect on air quality in the location, positive effect on the health of people, and it is also a solution to risk related with landfill landsliding, because in some cases we have heard that the piles of open dumps go very high, and it caused landsliding, harming the residents living nearby. Yes. So in terms of carbon credit opportunity, treating 1 ton of biodegradable material, it produces 0.4 ton of methane, meaning that if we treat waste, then it will save 0.4 ton of methane directly emitting into atmosphere, comparing it that if the waste is just thrown outside in the open dumps and landfill. And also 1 ton of bio-waste, biodegradable, equivalent to 3.575 tons of carbon dioxide savings. So this is in case carbon credit opportunity is available for certain cases. And there are social impacts, like job creation brings massive business activities to the country, turn waste to raw material, and also turns trash to cash, clean and healthy society, as I mentioned earlier, reduces burden on healthcare system, and improves tourism sector as well. Because in some capital city, if there are open dumps or landfills in the middle of the city, so this doesn't give good impression for tourists. So basically, it will clean the cities and improve tourism related activities as well. So finally, we have here this working roadmap that how Chemitec works in this waste to value related solutions for our clients and customers. So basically, we need to know that what type of waste to be treated, amount of waste available per day. We do technology assessment based on our in-house built softwares and tools, and this is in terms of choosing best technology route, economics involved, environmental impact, and then based on that we move further towards pre-feasibility study, feasibility study, and basic design and pre-engineering of the plant. So basically what we do that we prepare and present different options to the customer, and then we recommend that what suits best to their need, and of course then they can choose one of them, and then the route chosen is further we further proceed with this for feasibility study and pre-engineering and design. And at this stage, all technology supplying stakeholders are also on board with us. And this is phase project execution plan. It's phase 1, as I mentioned, is about concept and feasibility. Phase 2 is about engineering and procurement. Phase 3 is about construction, startup, and then finally operation and maintenance. It depends on the scale of project. However, the like large scale waste to energy projects may take like 24 to 30 months of time from start till operations. Yes, so we are open and available to discuss in details about your specific cases in separate meetings in terms of sharing our experience of techno-economics, possible business models, and roadmaps about your waste to value energy cases, and basically in which we can share with you that what type of solution will be most suitable for you, and what type of business models can be involved, and what technology routes are there for options and what type of economics are involved. So as Luis mentioned earlier, that after the presentation, there will be questions and answer and discussion session. I thank you very much for listening the presentation. And now please feel free to question or comment if you have any, or if you want to share your experience of waste to energy cases, that what type of solutions you are interested in. Yes, thank you.
Thank you, Dr. Nasrullah. Now we're going to move to the questions and answers. So please, from the audience, if you have any questions, unmute yourself and just ask the questions.